we're becoming cyborgs. And there's an interesting interplay between wires and biology, zeros and ones and the biological systems. And I don't think we'll have the luxury to see humans as disjoint from the technology we've created for much longer. We are an organisms that's...
Yeah. I mean, I agree with you, but we come really with this to consciousness.
Yes.
And is there a distinction there? Because what you're saying, the natural endpoint says we are indistinguishable, that if you are capable of building an AI which is sufficiently close and similar that we merge with it, then to all intents and purposes, that AI is conscious as we know it. And I don't have a strong view, but I have a view. And I wrote about it in the epilogue to my last book because 10 years ago, I wrote a chapter in a book called Life Ascending about consciousness. And the subtitle of Life Ascending was the 10 Great Inventions of Evolution. And I couldn't possibly write a book with a subtitle like that did not include consciousness, and specifically consciousness as one of the great inventions. And it was in part because I was just curious to know more, and I read more for that chapter. I never worked on it, but I've always, how can anyone not be interested in the question? And I was left with the feeling that A, nobody knows, and B, there are two main schools of thought out there with a big kind of skew in distribution. One of them says, it's a property of matter. It's an unknown law of physics. Panpsychism, everything is conscious. The sun is conscious. It's just a matter of, or a rock is conscious. It's just a matter of how much. And I find that very unpersuasive. I can't say that it's wrong. It's just that I think we somehow can tell the difference between something that's living and something that's not. And then the other end is it's an emergent property of a very, very complex central nervous system. And I never quite understand what people mean by words like emergence. I mean, there are genuine examples, but I think we very often tend to use it to plaster over ignorance. As a biochemist, the question for me then was, okay, it's a concoction of a central nervous system. A depolarizing neuron gives rise to a feeling of pain, or to a feeling of love, or anger, or whatever it may be. So what is then a feeling in biophysical terms in the central nervous system? Which bit of the wiring gives rise to... And I've never seen anyone answer that question in a way that makes sense to me.
And that's an important question to answer.
I think if we want to understand consciousness, that's the only question to answer. Because I certainly an AI is capable of outthinking, and it's only a matter of time. Maybe it's already happened. In terms of just information processing and computational skill, I don't think we have any problem in designing a mind which is at least the equal of the human mind. But in terms of what we value the most as humans, which is to say our feelings, our emotions, our sense of what the world is in a very personal way, that I think means as much or more to people than their information processing. And that's where I don't think that AI necessarily will become conscious, because I think it's a property of life.
Well, let's talk about it more. You're an incredible writer, one of my favorite writers. So let me read from your latest book, Transformers, what you write about consciousness. "I think, therefore I am," said Descartes, is one of the most celebrated lines ever written. But what am I exactly? An artificial intelligence can think too, by definition, and therefore is. Yet few of us could agree whether AI is capable, in principle, of anything resembling human emotions, of love or hate, fear and joy, of spiritual yearnings for oneness or oblivion, or corporeal pangs of thirst and hunger. The problem is we don't know what emotions are, as you were saying. What is the feeling in physical terms? How does a discharging neuron give rise to a feeling of anything at all? This is the hard problem of consciousness. the seeming duality of mind and matter, the physical makeup of our innermost self. We can understand in principle how an extremely sophisticated parallel processing system could be capable of wondrous feats of intelligence, but we can't answer in principle whether such a supreme intelligence would experience joy or melancholy. What is the quantum of solace? Speaking to the question of emergence, there's just technical. There's an excellent paper on this recently about the this kind of phase transition, emergence of performance in neural networks on the problem of NLP, natural language processing. So language models. There seems to be this question of size. At some point, there is a phase transition as you grow the size of the neural network. So the question is, this is sort of somewhat of a technical question that you can philosophize over. The technical question is there a size of a neural network that starts to be able to form the kind of representations that can capture a language and therefore be able to, not just language, but linguistically capture knowledge that's sufficient to solve a lot of problems in language, like be able to have a conversation. And there seems to be not a gradual increase, but a phase transition. And they're trying to construct the science of where that is. Like, what is a good size of a neural network, and why does such a phase transition happen? Anyway, that sort of points to emergence. That there could be stages where a thing goes from being, oh, you're very intelligent toaster, to a toaster that's feeling sad today and turns away and looks out the window, sighing, having an existential crisis.
Thinking of Marvin, the paranoid android.
Exactly. Well, no, Marvin is simplistic because Marvin is just cranky.
Yes.
So
easily programmed.
Yeah, easily programmed, nonstop existential crisis. You're almost basically what is it? Notes from Underground by Dostoevsky. Like just constantly complaining about life. No, they're capturing the full roller coaster of human emotion, the excitement, the bliss, the connection, the empathy, and all that kind of stuff, and then the selfishness, the anger, the depression, all that kind of stuff. Capturing all of that and be able to experience it deeply, like it's the most important thing you could possibly experience today. The highest highs, the lowest lows. This is it. My life will be over. This I cannot possibly go on. That feeling, and then like after a nap, you're feeling amazing. That might be something that emerges.
So why would a nap make an AI being feel better?
First of all, we don't know that for a human either, right?
But we do know that that's actually true for many people much of the time. You may be utterly depressed and you have a nap and you do, in fact, feel better. So,
you are actually asking the technical question there is there. So there's a biological answer to that. And so the question is whether AI needs to have the same kind of attachments to its body, bodily function, and preservation of the brain's successful function. Self-preservation, essentially, in some deep biological sense.
I mean, to my mind, it comes back round to the problem we were talking about before about simulations and sensory input and learning what all of this stuff means, and life and death. That biology, unlike society, has a death penalty over everything, and natural selection works on that death penalty. That if you make this decision wrongly, you die. And the next generation is represented by beings that made a slightly different decision on balance. And that is something that's intrinsically difficult to simulate in all its richness, I would say. So what is
death in all its richness? Our relationship with death, or the whole of it. So, when you say richness, of course, there's a lot in that.
Yeah.
Which is hard to simulate. What's part of the richness that's hard to simulate?
I suppose the complexity of the environment and your position in that, or the position of an organism in that environment, in the full richness of that environment over its entire life, over multiple generations, with changes in gene sequence over those generations, so slight changes in the makeup of those individuals over generations. But if you take it back to the level of single cells, which I do in the book, and ask how does a single cell in effect know it exists as an unit, as an entity? I mean, no, in inverted commas, obviously it doesn't know anything, but it acts as a unit, and it acts with astonishing precision as a unit. And I had suggested that that's linked to the electrical fields on the membranes themselves, and that they give some indication of how am I doing in relation to my environment as a kind of real-time feedback on the world. And this is something physical, which can be selected over generations, that if you get this wrong, it's linked with this set of circumstances that I've just, as an individual, I have a moment of blind panic and run. Mm-hmm. As a bacterium or something, you have some electrical discharge that says blind panic, and it runs, whatever it may be. And you associate over generations, multiple generations, that this electrical phase that I'm in now is associated with a response like that. And it's easy to see how feelings come in through the back door almost, with that kind of giving real-time feedback on your position in the world in relation to how am I doing. And then you complexify the system, and yes, I have no problem with phase transition, and can all of this be done purely by the language, by the issues with how the system understands itself? Maybe it can. I honestly don't know. Well, but the philosophers for a long time have talked about the possibility that you can have a zombie intelligence, and that there are no feelings there, but everything else is the same. I have to throw this back to you, really. How do you deal with a zombie intelligence?
So, first of all, I can see that from a biologist perspective, you think of all the complexities that led up to the human being. The entirety of the history of 4 billion years that in some deep sense integrated the human being into its environment, and that dance of the organism and the environment, you could see how emotions arise from that, and their emotions are deeply connected and creating a human experience, and from that you mix in consciousness and the full mess of it. But from a perspective of an intelligent organism that's already here, like a baby that learns, it doesn't need to learn how to be a collection of cells or how to do all the things it needs to do. It's the basic function of a baby as it learns is to interact with its environment, to learn from its environment, to learn how to fit in to this social society, to
and the basic response of the baby is to cry a lot of the time.
Cry, maybe convince the humans to protect it, or to discipline it, to teach it, to whatever. I mean, we've developed a bunch of different tricks, how to get our parents to take care of us, to educate us, to teach us about the world. Also, we've constructed the world in such a way that it's safe enough for us to survive in, and yet dangerous enough for learn the valuable lessons. Like the tables are still hard with corners, so it can still run into them. It hurts like hell. So AI needs to solve that problem, not the problem of constructing this super complex organism that leads up. To run the whole, to make an apple pie, to build the whole universe, you need to build the whole universe. I think the zombie question is it's something I would leave to the philosophers, because. And I will also leave to them the definition of love and what happens between two human beings when there's a magic that just grabs them like nothing else matters in the world. And somehow you've been searching for this feeling, this moment, this person your whole life. That feeling the philosophers can have a lot of fun with that one, and also say that that's just you can have a biological explanation. You can have all kinds of. It's all fake. It's actually Ayn Rand will say it's all selfish. There's a lot of different interpretations. I'll leave it to the philosophers. The point is the feeling sure as hell feels very real. And if my toaster makes me feel like it's the only toaster in the world, and when I leave and I miss the toaster, and when I come back, I'm excited to see the toaster, and my life is meaningful and joyful, and the friends I have around me get a better version of me because that toaster exists. That sure as hell feels
I
like a
mean,
conscious toaster.
is that psychologically different to having a dog?
No,
Because I mean,
exactly.
most people would dispute whether we can say a dog. I would say a
Has
dog is
consciousness.
undoubtedly conscious, but
Yes.
but some people would
But
say
there's
it doesn't.
degrees of consciousness and so on. But people are definitely much more uncomfortable saying a toaster can be
Yes,
conscious
yes.
than a dog. And there's still a deep connection. And you could say our relationship with the dog has more to do with anthropomorphism. Like we kind of project a human being onto it.
Maybe.
We can do the same damn thing with a toaster.
Yes, but you can look into the dog's eyes and you can see that it's sad, that it's delighted to see you again. I don't have a dog, by the way. It's not that I'm a dog
And
person.
dogs
or a cat
are actually
person.
incredibly good at using their eyes to do just that.
They are. Now, I don't imagine that a dog is remotely as close to being intelligent as an AI intelligence.
Yes.
But it's certainly capable of communicating emotionally with us.
But here's what I would venture to say. We tend to think because AI plays chess well and is able to fold proteins now well, that it's intelligent. I would argue that in order to communicate with humans, in order to have emotional intelligence, it actually requires another order of magnitude of intelligence. It's not easy to be flawed. Solving a mathematical puzzle is not the same as the full complexity of human to human interaction. That's actually, we humans just take for granted the things we're really good at. Nonstop, people tell me how shitty people are at driving. No, humans are incredible at driving. Bipedal walking, object manipulation. We're incredible at this. And so people tend to
discount the things we all just take for granted.
And one of those things that they discount is our ability, the dance of conversation and interaction with each other, the ability to morph ideas together, the ability to get angry at each other and then to miss each other, like to create a tension that makes life fun and difficult and challenging in a way that's meaningful. That is a skill that's learned. And AI would need to solve that problem.
I mean, in some sense, what you're saying is AI cannot become meaningfully emotional, let's say, until it experiences some kind of internal conflict that is unable to reconcile these various aspects of reality or its reality with a decision to make. And then it feels sad necessarily because doesn't know what to do. And I certainly can't dispute that. That may very well be how it works. I think the only way to find out is to do it. And
to build it, and leave it to the philosophers if it actually feels sad or not. The point is, the robot will be sitting there alone, having an internal conflict, an existential crisis, and that's required for it to have a deep, meaningful connection with another human being. Now, does it actually feel that? I don't know.
But I'd like to throw something else at you, which troubles me on reading it. Noah Harari's book, 21 Lessons for the 21st Century, and he's written about this kind of thing on various occasions. And he sees biochemistry as an algorithm. And then AI will necessarily be able to hack that algorithm and do it better than humans. So there will be AI better at writing music that we appreciate than Mozart ever could, or writing better than Shakespeare ever did, and so on, because biochemistry is algorithmic, and all you need to do is figure out which bits of the algorithm to play to make us feel good or bad or appreciate things. And it's as a biochemist, I find that argument close to irrefutable and not very enjoyable. I don't like the sound of it. That's just my reaction as a human being. You might like the sound of it because that says that AI is capable of the same kind of emotional feelings about the world as we are, because the whole thing is an algorithm, and you can program an algorithm, and there you are. He then has a peculiar final chapter where he talks about consciousness in rather separate terms, and he's talking about meditating and so on, and getting in touch with his inner conscious. I don't meditate, I don't know anything about that. But he wrote in very different terms about it, as if somehow it's a way out of the algorithm. Now, it seems to me that consciousness, in that sense, is capable of scuppering the algorithm. I think in terms of the biochemical feedback loops and so on, it is undoubtedly algorithmic. But in terms of what we decide to do, it can be much more based on an emotion. We can just think, I don't care. I can't resolve this complex situation. I'm going to do that. And that can be based on, in effect, a different currency, which is the currency of feelings, and something where we don't have very much personal control over. And then it comes back around to you, and what are you trying to get at with AI? Do we need to have some system which is capable of overriding a rational decision which cannot be made because there's too much conflicting information, by effectively an emotional, judgmental decision that just says, do this and see what happens?
Yeah,
that's what consciousness is really doing, in my view.
Yeah, and the question is whether it's a different process or just a higher level process. I might, the idea that biochemistry is an algorithm is, to me, an oversimplistic view. There's a lot of things that the moment you say it, it's irrefutable, but it simplifies.
I'm sure it's an
And
extremely
in the
complex system,
process, loses something fundamental. So, for example, calling a universe an information processing system, sure, yes, you could make that. It's a computer that's performing computations, but you're missing the process of the entropy somehow leading to pockets of complexity that creates these beautiful artifacts that are incredibly complex, and they're like machines. And then those machines are, through the process of evolution, are constructing even further complexity. Like, in calling universe information processing machine, you're missing those little local pockets and how difficult it is to create them. So the question to me is, if biochemistry is an algorithm, how difficult is it to create a software system that runs the human body, which I think is incredible. I think that is going to take so long. That's going to be centuries from now to be able to reconstruct a human. Now, what I would venture to say, to get some of the magic of a human being, with what we saying, with the emotions and the interactions, and like a dog makes us smile and joyful and all those kinds of things, that will come much sooner. But that doesn't require us to reverse engineer the algorithm of biochemistry.
Yes, but the toaster is making you happy.
Yes,
it's not about whether you make the toaster happy.
No, it has to be.
So
it has to be. It has to be. The toaster has to be able to leave me
happy. Yes, but it's the toaster is the AI in this case. Is a very intelligent.
Yeah, the toaster has to be able to be unhappy and leave me. That's essential.
Yeah,
that's essential for my being able to miss the toaster. If the toaster is just my servant, that's not, or a provider of like services, like tells me the weather and makes toast, that's not going to deep connection. It has to have internal conflict. You write about life and death. It has to be able to be conscious of its mortality and the finiteness of its existence, and that life is temporary, and therefore needs to be more selective.
One of the most moving moments in the movies from when I was a boy was the unplugging of Hal in 2001, where that was the death of a sentient being, and Hal knew it. So I think we all kind of know that a sufficiently intelligent being is going to have some form of consciousness, but whether it would be like biological consciousness, I just don't know. And if you're thinking about how do we bring together, obviously we're going to interact more closely with AI, but are we really? Is a dog really like a toaster? or is there really some kind of difference there? You were talking biochemistry is algorithmic, but it's not a single algorithm, and it's very complex. Of course it is. So it may be that there are, again, conflicts in the circuits of biochemistry, but I have a feeling that the level of complexity of the total biochemical system at the level of a single cell is less complex than the level of neural networking in the human brain or in an AI.
Well, I guess I assumed that we were including the brain in the biochemistry algorithm, because you have to.
I would see that as a higher level of organization of neural networks. They're all using the same biochemical wiring within themselves.
Yeah, but the human brain is not just neurons. It's the immune system. It's the whole package. I mean, to have a biochemical algorithm that runs a intelligent biological system, you have to include the whole damn thing. And it's pretty fascinating that it comes from an embryo. Like the whole, I mean, boy. I mean, if you can, what is a human being? Because
but if you look
it's just some code, and then you build, and then so it's DNA doesn't just tell you what to build, but how to build it. I mean, the thing is impressive, and the question is how difficult is it to reverse engineer the whole shebang?
Very difficult.
I would say it's, don't want to say impossible, but it's much easier to build a human than to reverse engineer, to build like a fake human-like thing, than to reverse engineer the entirety of the process that evolution had
I'm not sure if we are capable of reverse engineering the whole thing.
Yeah.
If the human mind is capable of doing that. I mean, I wouldn't be a biologist if I wasn't trying.
Yeah.
But I know I can't understand the whole problem. I'm just trying to understand the rudimentary outlines of the problem. There's another aspect, though. You're talking about developing from a single cell to the human mind and all the subsystems that are part of it, the immune system and so on. This is something that you'll talk about, I imagine, with Michael Levin, but so little is known about, you talk about reverse engineering, so little is known about the developmental pathways that go from a genome to going to a fully wired organism. And a lot of it seems to depend on the same electrical interactions that I was talking about happening at the level of single cells and its interaction with the environment. There's a whole electrical field side to biology that is not yet written into any of the textbooks, which is about how does an embryo develop into, or a single cell develop into these complex systems? What defines the head? What defines the immune system? What defines the brain? And so on. That really is written in a language that we're only just beginning to understand. And frankly, most biologists are still very reluctant to even get themselves tangled up in questions like electrical fields influencing development. It seems like mumbo jumbo to a lot of biologists, and it should not be, because this is the 21st century biology. This is where it's going. But we're not going to reverse engineer a human being or the mind or any of these subsystems until we understand how this developmental process works, how electricity in biology really works. And if it is linked with feelings and with consciousness and so on, that's I mean, in the meantime, we have to try. But I think that's where the answer lies.
So you think it's possible that the key to things like consciousness or some of the more tricky aspects of cognition might lie in that early development, the interaction of electricity and biology, electrical fields.
But we already know the EEG and so on is telling us a lot about brain function, but we don't know which cells, which parts of a neural network is giving rise to the EEG. We don't know the basics. The assumption is, I mean, we know it's neural networks. We know it's multiple cells, hundreds or thousands of cells involved in it. And we assume that it's to do with depolarization during action potentials and so on. But the mitochondria, which are in there, have much more membranes than the plasma membrane of the neuron, and there's a much greater membrane potential. And it's formed in very often parallel cristae, which are capable of reinforcing a field and generating fields over longer distances. And nobody knows if that plays a role in consciousness or not. There's reasons to argue that it could, but frankly, we simply do not know. And it's not taken into consideration. You look at the structure of the mitochondrial membranes in the brains of simple things like Drosophila, the fruit fly, and they have amazing structures. You can see lots of little rectangular things all lined up in amazing patterns. What are they doing? Why are they like that? We haven't the first clue.